So what happens when we disturb an equilibrium? Le Chatelier's principle says that when a chemical system at equilibrium is disturbed, the system shifts in a direction that minimizes the disturbance. Le Chatelier was a guy who studied equilibrium reactions long, long time ago. Another way to say this is a system at equilibrium fights back when it's disturbed. Okay, it's like we want to maintain the status quo. We settled out and we've got everything level and how we like it, and then you come in and you start messing with us. So we're going to shift around to try to get back to where we were. If you increase this one thing, we're going to do something to decrease that. If you decrease this, we're going to do something to increase it. We want to go back to where we were. So the system is fighting back, is a good way to think of it. So let's go back to our population analogy. So we were talking about immigration. Yeah. Immigration from Narnia into Middle-earth. And it kind of settled out because originally Narnia was overpopulated and Middle-earth was underpopulated. And so people moved to Middle-earth because there was more opportunity there. And it kind of settled out, and so the populations on each side were relatively constant, even though there were people moving back and forth, because people always think it's better on the other side, right? The grass is always greener on the other side of the fence. Well, what happens now if we dump a bunch of new people into Middle-earth? Some of you may think, well, where did those people come from? I don't know. They came from outer space. They didn't come from Narnia. They're just like dropping in here into our little system here. So we got a whole bunch of people added to Middle-earth. This is an equilibrium. It's going to react in a way to fight back, to counteract that change that was made. So we added a lot of people here, so that's going to increase the number of people that move to Narnia. In an equilibrium, we have reactions going in both directions. And we talked about rates of reactions. The rate of the reaction in the forward direction here is going to depend in part on the concentration of the reactants. We talked about collision theory and how things have to collide to react. And if you have a more concentrated situation, you're going to have more collisions, and the rate of reaction is going to be faster. So when we add a bunch of people to this side, we've increased the concentration. That increases the rate of people moving to Narnia. And that's going to cause the population to shift over here, is going to cause this to go down. Not back to where it was, but it's going to go down as far as it can. Because we added something here, and the equilibrium shifts to counteract that. You added a bunch of stuff here, well, we're going to move over here to reduce what you did to us. Okay? What would happen if, instead of adding people over here, if we took a bunch of people out? What would happen? How would this shift? Would it shift? Would people move over here, or would people move over to Narnia more? If we removed a whole bunch of people from Middle-earth. I think I can actually do that. I'm going to erase them, just because I could. Just pick a color here. Maybe that color. So I'm just going to get rid of a bunch of people. Well, those guys lost their legs. That's unfortunate. Now there's a lot less people over there. What's going to happen? People are going to move from Narnia to Middle-earth. We reduce the population, so the equilibrium is going to shift in a way to increase the population again. Does that make sense? The only way to get these, there will be questions, they're not really math questions, but they're thinking questions on an exam. The only way to get these correct is to understand what's going on here, how the balance is going.